Okay, in the previous class, we started the design of culvert. The problem statement like this: design a reinforced concrete slab culvert for a national highway crossing to suit the following data. Data are they have given the width of the carriageway, that is 7.5 meter wide. Footpath is given 1 meter on either side. Clear span is given 6 meter. Bearing court and width of the bearing is given. So we have seen all this in the previous class, and they have also given the what type of loading we need to apply. Uh, Loading is IRC class AA tracked vehicle. Okay. So this is the very small bridge that we have, and the clear distance is 6 meter. Okay. And the bridge is supported on the bearing. And we need to assume here they have not given, sorry, they have given the width of the bearing. We don't have to assume, they have given the width of the bearing, that is 400 mm. Okay. So we have written the clear width of the bearing. The loading is IRC class AA tracked vehicle. It is not wheeled vehicle. The loading is tracked vehicle. So very first step is to find the depth of the slab. This is the bridge is also known as slab culvert because it is a small bridge. When you come from Khandeshwar station to Culvert College, you will get a small bridge, and that bridge is known as culvert. It is also known as slab culvert. So by using this ratio L by D equal to 15 or L by D equal to 12, you can find the overall depth. So overall depth here you are getting 400 and here you are getting 500. And there is also thumb rule by which you can find the overall depth of the bridge. 80 mm per meter span of the bridge. So 80, the span of the bridge is 6 meter, 826, you're getting 480, okay? And you can find the small d by using this formula. You can check my video to see all this detail. Then you need to find the effective span. Effective span we have gotten 6.45 and 6.4 least we need to take. And this is the cross section view of the bridge. So you have the depth of the slab, the overall depth of the slab is 500 mm. Then you have 1 meter width on either side, 1 meter footpath on either side, and you have wearing coat, that is 80 mm. Okay. Then you need to find dead load bending moment, dead load of the slab. The total total depth of the slab is zero point 0.5 into 24, and dead load of the wearing coat, the density of the wearing coat is 22. Okay, so you are getting total dead load. From total dead load, you can find bending moment with respect to the dead load. We need to find live load bending moment. To find live load bending moment, you need to refer IRC 6 2017, page number 31. Okay, so we'll start today's class. By finding the live load bending moment. Already in the previous class, we have calculated the dead load bending moment. In this class, we will see how to find the live load bending moment. Okay. So live load bending moment. See, whenever the live load is acting on the bridge, it will have some impact. It will have some impact on the bridge. So whenever you are considering live load, you also have to consider the impact factor. Okay, impact factor is given in IRC 6. There is a whole chapter which discusses about the impact factor. So what is the impact factor for different kinds of loading? If you are dealing with IRC class AA tracked vehicle, what is the impact factor? If you're dealing with the wheeled vehicle, what is the impact factor? If you're dealing with class A loading, what is the impact factor? So all set of impact factor is given in IRC 6 2017. You can refer that. Okay. So the impact factor for IRC class AA tracked vehicle, I will write here IRC class AA tracked vehicle. The impact factor is 25% for 5 meter and 10% for 9 meter. So our effective span is 6.4. So the impact factor for 5 meter bridge is 25% for tracked vehicle, class W tracked vehicle, and it is linearly decreasing to 10% for 9 meter. So how to find for 6.4? We have to interpolate and we need to find the impact factor for the span 6.4 meter. Okay. So this is 5 meter. For the 5 meter, the impact factor is 25%. For 9 meter, the impact factor is 10%. And for 6.4 meter, the impact factor will be 19.7%. Okay, so this is the impact factor. Next, you need to find the dispersion along the length. Now, you see, this is the bridge that you have. This is the bridge that you have, okay? And the load is acting like this. You need to place the load at the center so that you will get the maximum bending moment. The contact distance is for class AA track vehicle, the contact length is 3.6 meter. And you need to find this W. We will see how to find the W. But try to understand that the contact length of the track vehicle is 3.6 meter. So we need to find the dispersion along the length. So you see this load, this is the load, and it will disperse in 45-degree angle. Okay. So below this you have the wearing code. You have the wearing code and you also have the depth of the slabs. So this is 3.6 meter. It will disperse in this direction. Okay. So you need to consider, so this is the wearing code and this is the depth of the slab. Okay. The wearing code is 80 mm and overall depth of the slab is 500 mm. So you need to find dispersion length. Since it is dispersing in 45-degree angle, so what will be the dispersion length? I will tell you. Dispersion along the length. Write down this. Dispersion, dispersion along the length. Along the length. Okay. So equal to 3.6 plus 2 into 0.08 plus 0.5. What is 0.08? See, this distance will be same when you are, dispersing in 45-degree angle, the vertical length and the horizontal length will remain same. Okay. Even this length is 0.5 and this is 0.08. Here also, this is 0.008 and this is 0.5. So total dispersion length along the length is 3.6 plus 2 into 0.08 because in both the side you have 0.08 plus zero point 0.5. In both the side you have the 0.5. So this is the dispersion length that you're getting, 4.76 meter. Dispersion along the length of the bridge. You also have to find dispersion along the width of the bridge. Dispersion along the length of the bridge is 4.76. Okay. Now you need to find dispersion. I will tell you what is the purpose of this, why we are doing this. Try to understand what I'm telling you. We are interested in finding dispersion along the length which we have just calculated, and we are also interested in finding dispersion along the width. Okay. So I'll write here dispersion along the width, dispersion along the width. For that, you need to refer one formula which is given in IRC 112 2020, page number 240. Dispersion along the width is complicated. Dispersion along the length is very easy stuff. You just have to, add these two value and you will get the dispersion length. Dispersion along the width is complicated. You need to understand some formulas given by IRC. Okay. So one uh, term is there, effective width. Effective width, effective width of slab, effective width of slab perpendicular to span, perpendicular to span. Okay. So this formula is given in IRC 112 2020, page number 240. Okay, so the formula is BE equal to K into X bracket 1 minus X divided by L naught plus BW. This formula is given. So we will try to understand what is this formula and what the meaning of this formula is. What we are getting from this formula. Okay. So first we will see the terms in the formula. B effective. This is B effective. Okay. B effective is the effective width of the slab on which the load act. Effective width of the slab. Dispersion along the width of the slab. Okay. So this is the effective width of slab on which the load acts, on which the load acts, the load acts. We'll see physically what is the meaning of this. First, we will see all the terms. L naught is the effective span. L naught here is the effective span. Already we know what is our effective span in this particular bridge. The effective span is 6.4 meter. We have seen that how we have calculated the effective span in the previous class. You can also refer to the recording. Okay. What is X? I will tell you. What is X? X is the distance of the center of gravity of the load from the nearer support. The distance of the center of gravity of load from the nearer support, from the nearer support. So we will see physically how we can understand all these terms. First, we will see what are the different terms that we have. Next, we have BW. BW equal to BW equal to dispersion of single track up to the wearing port. Dispersion of single track up to the wearing port. Up to the wearing port. I think you have learned, this all these terms in the first semester in, in advanced pre-stress. Hasib, have you learned all these terms? Is this something new for you, or already you are aware of all these terms? Let me know. Hasib, Salunke,
Yes, sir.
ये टर्म आपको पता है? आपने एक सर आए थे
Yes,
ना
sir.
साबु सिद्दीक से, तो उन्होंने सारी चीजें बताए थे आपको?
Yes, sir.
ओके, तो उसका हम उसका रिवीजन ही कर रहे हैं, ठीक है। Or what is K? K is a constant. It's a constant having the following values. It depends on, okay, it's a constant. It depends on B by L naught value. Depends on capital B by L naught, where L naught is the effective span of the bridge and B is the total width of the bridge. Okay, I will draw the cross section and you will able to understand what we have to do. Okay, so this is your bridge. This is your bridge that you have. This is how the bridge will look. Okay, this is how the bridge will look. Then this is the depth of the slab that you have. This is the depth of the slab you have. And you're providing 80 mm wearing coat, which will be above the concrete. 80 mm wearing coat. Depth of the slab is 500 mm and the wearing coat is 80 mm. And you're putting load here like this. We are dealing with IRC class AA tracked vehicle, which will have two tracks. Okay, so these are the tracks that you have, which will be placed. I have also explained you the margin, you know, margin for class AA, margin for class A. You see my video, previous video, and you will understand what is margin. So where we need to put the load from the footpath. Okay. So at 1.2 meter distance, we need to put this load. Okay. And this will disperse in this section. It will disperse. Okay. So the dispersion, the total dispersion of single track, you see, this is the single track that we have. The total dispersion, no, dispersion not up to the wearing put. The total dispersion is nothing but B effective. You got this? The total dispersion of single track, see, this is how it is dispersing in the 45-degree. The total dispersion of single track is known as B effective. And first we need to find this B effective, and then we need to find the total dispersion of both the track. So this is the distance of the total dispersion along the width. See, already we have calculated dispersion along the length, and now we are interested to find dispersion along the width. Okay, so first we will find this B effective. B effective, okay? You will find the B effective. Now you see, this is your bridge that you have, and the load has to be placed at the center. It has to be placed at the center, and already we have calculated the dispersion length. Dispersion length. What is the dispersion length? 4.760. Okay, so and what is x? X in the formula you have x. What is x? X is nothing but the distance of the center of gravity of the load. So this is the center of gravity of the load from the nearer support. So both supports are at the same distance. You take any support. Total length of the bridge is 6.4 meter. Okay. And the x distance will be equal to 3.2 meter. So x equal to 3.2 meter. Okay. L naught, that is effective span, which is equal to 6.4 meter. B, the width of the bridge. Width of the bridge. You see, the width of the bridge, I have drawn the cross section. What is the width of the carriageway? It is given in the problem. This is 7.5 meter. The width of the carriageway or the width of the road. Then on either side, you have the footpath of 1 meter and 1 meter. 1 meter, 1 meter. So what will be the total width of the bridge? The total width of the bridge is 9.5 meters. 7.5 meter plus 1 plus 1 You're getting 9.5 meter. So total width of the bridge is 9.5 meter. Okay. Now K value, I told you, K value depends on B by L value. L, what is L? L is effective span. So what is B? B is 9.5 divided by L. L is effective span, that is 6.4 meter. So this you are getting it as 1.48. So from the table given in 112, I will open the 112. I'll open 112. Give me some time. I will just share the screen. My screen is visible to all of you.
Yes, sir.
Okay, so I will show you 112. Uh, where I have downloaded. Okay, let me see. Okay, this is bridge engineering. In the bridge engineering, I have IS code. Which IS code we need to refer? 112. Okay. This is previous version and it has been referred latest version. Okay, you see the value IRC 112 2020. I think in the last page they have given the value of K. All of you have code.
Yes, sir.
This is not coming. Give me some time. It is taking time to load. Okay, now we can see. I will go to last page, 296. Okay, this is not getting, open. I will tell you. Can you hear me, class? Hello,
Yes,
class.
sir.
Can you hear me? I will tell you how to take the value. Uh,
Yes.
okay. So you have to refer page number 241 of IRC 112. Page number, page number 241, okay, of IRC 112 2020. So in this page, there is one table. They have also given the formula. Okay, be effective, whatever the formula that we have discussed, that formula is also given, and they have given one table in page number 241. I will write that table. Here you have B by L value. In the table, you have B by L not value. Then you have K or alpha. In code, they have given alpha, but in our discussion, we have written K. Okay, alpha for simply supported, simply supported slab, simply supported slab. Okay, and they have also given alpha for continuous slab, continuous slab. So what is our slab? Can anyone tell me what is our slab? And they have given value zero point 0.1, zero point 0.2, up to 3. Up to 3, they have given the B by L naught value. And we need to find alpha for simply supported slab and for alpha for continuous slab. What is our slab? Is it a simply supported slab or a continuous slab? What is our slab? Hasid, is it simply supported bridge or a continuous bridge? See,
Continuous.
our bridge is no, it is not continuous. It is simply support. It is a simple slab culvert. Okay, it is simply supported slab. So here they have given the values, and between the two values, our value is 1.48. Okay, 1.48 means we need to see between 1.4 and 1.5. For 1.4, K value for simply support is 2.80. For 1.5, the K value is 2.84. And we need to find it for 1.48. You can do the interpolation and you can find the value of K. The K value is 2.84. You can take 2.84 also because it is very near to 1.5. Okay, don't have to interpolate if it is very near to any value. So you can take 2.4. Okay, then you can use this formula B effective. I will write the formula. B effective, B effective equal to K into X 1 minus X divided by L naught plus BW. What is this BW? I will tell you. BW is dispersion of, see, this is the single track that you have. Single track that you have. Okay. This is the single track that you have. The width of this track is 0.85. Below this track, you have wearing coat and you have depth of the slab. So this is the dispersion up to the wearing coat only. You don't have to find the total dispersion. BW is dispersion of single track up to the wearing coat only. So this is your BW. So you only have to add 0.08, 0.08. Okay. So BW equal to 0.85 plus 2 into 0.08. So I have not taken the depth of this slab because we are not finding the total dispersion. What is BW? BW is the dispersion of single track up to the wearing coat only. Okay, that is why we have only taken the depth of the wearing coat. So BW value is 1.01. Now we can put we got all the values. In the formula, we can put that value. So B effective equal to K is 2.84 into X is 3.2, 1 minus X is 3.2 divided by 6.4 plus 1.01. So this is coming as B effective is coming as B effective equal to 5.56 meter. And what is B effective? B effective is the dispersion of total dispersion of single tracks. I told you in the diagram, you know, in the diagram itself, I told you what is B effective. B effective is total dispersion of one is dispersion up to the wearing code. This is the dispersion up to the wearing code, and this is BW. Just now we have calculated. And what is total dispersion? This is the total dispersion that we have. The total dispersion is B effective. Okay. Now we have gotten, this is B effective. And what will be this? B effective by 2. Am I right? Anyone can tell me, am I right? What will be this? B effective by 2. Hasib, are you there?
Yes,
Anyone
yes,
is
sir.
following
B
me?
you by 2.
B effective by 2. Okay, so what is B effective? 5.56. So 5.56 divided by 2. Now, see, we are interested in this distance. ये distance हमें चाहिए यहाँ से यहाँ तक. तो हमें यहां से यहां तक का डिस्टेंस मिला है बी इफेक्टिव बाय 2. ठीक है. अब मुझे बताओ ये डिस्टेंस कितना रहेगा. व्हाट विल बी दिस डिस्टेंस. देखो यहां से
Point
यहां तक तो
four.
हमें 0.85 डिवाइडेड बाय 2.
Yes, sir.
ठीक है, ये 0.85 डिवाइडेड. यहां से यहां तक का डिस्टेंस हमें पता है, हमने आईआरसी लोडिंग देखा है, ये 1.2 है ना. और ये डिस्टेंस कितना है? 0.85. ये कितना है फिर? मार्जिन कितना है? व्हाट इज द मार्जिन? 1.2. एंड व्हाट इज द फुटपाथ? फुटपाथ इज 1 meter. See, from here to here, we need to find the total dispersion. So I will write here total dispersion along the width. See, already we have calculated total dispersion along the length, and that is very easy stuff. And this is something which is very complicated. You finding total dispersion along the width. Okay, so I will write here total dispersion along the width. Total dispersion along the width equal to, see, B effective divided by 2. यहाँ से यहाँ का डिस्टेंस. ठीक है, यहाँ से यहाँ तक का डिस्टेंस. इसके बाद यहाँ से यहाँ तक का डिस्टेंस. इसके बाद क्या है? प्लस 0.85 डिवाइडेड बाय 2. यहाँ से यहाँ तक का डिस्टेंस क्या है? 0.85 डिवाइडेड बाय 2. फिर यहाँ से यहाँ तक क्या है? प्लस 1.2 प्लस ये क्या, फिर प्लस 1.2 के बाद क्या है? 0.85. 0.85. उसके बाद मार्जिन है. मार्जिन कितना है आपका? प्लस 1.2. ओके. देन द फुटपाथ इज 1 meter. So this is the total dispersion along the width. Okay. So total dispersion along the width is, can anyone calculate and tell me the value? What is the value? What is this value? What is this value? Total dispersion along the width. कोई कैलकुलेट करके बताएगा? हसीब.
एक मिनट से कर रहा हूँ.
5.56 divided by 2, okay, plus 0.85 divided by 2 plus 1.2 plus 0.85 plus 1.2 plus 1. 7.455.
Yes,
45.
7.455.
Okay, 7.455 meter. So this is the total dispersion along the width. See, we have calculated the dispersion along the length. that is 4.76. And now we have calculated dispersion along the width. Okay. So see, we have to find this intensity of the load. We don't know what is the intensity of load. Okay, we need to find that. I will give one formula by which you can find the intensity of the loading. Okay, so I will draw the beams. This is your beams, or not beam, the bridge that you have, and total distance is 6.4 meter, and you have calculated dispersion along the length. See, this is not contact length, this is dispersion along the length, that is 4.76 meter. Okay, you are interested to find this, intensity of the load. So the average intensity of load, I will write the formula here. Average intensity of load equal to total load